The nodal coordinates of the triangular element are shown in figure. At the interior point P, the x coordinate is 3.3 and n1 is equal to 0.3. Determine n2, n3 and the y coordinate at point P. The nodal coordinates of the triangular element are shown in figure. At the interior point P, the x coordinate is 3.33 and n1 is equal to 0.3. Determine the y coordinate at point P. As shown in figure, first node, second node and third node points 1, 2, 5, 3, 4 and 6. At interior point P is x comma y. So solution: x1 y1 is equal to 1 2, x2 y2 is equal to 5 3, x3 y3 is equal to 4 comma 6. And x is equal to 3.33, n1 is equal to 0.3 and n1 is equal to j is equal to 0.3. Determine y point and n2 and n3. X is equal to 3.33, n1 is equal to 0.3 and n1 is equal to j is equal to 0.3. Determine y point n2 and 3. So x is equal to n1 x1 plus n2 x2 plus n3 x3. Here n1 is equal to xi and n2 is equal to neta, n3 is equal to 1 minus j minus neta. Therefore, xi into x1 plus n2 x2 plus 1 minus neta minus j x3. Xi x1 neta x2 plus 1 minus j minus neta x3, that equal to j x1 neta x2 x3 minus j x3 minus neta x3. x1 minus x3 j x2 minus x3 neta plus x3. That is x value substitute 3.3, x1 is 1, x3 is minus 4, xi plus x2 is 5, x3 is 4, neta plus 4, that equal to 3.33 minus 3xi minus neta plus 4. 3.33 minus 3 into 0.3 minus neta plus 4, that equal to 3.33 equal to minus 0.9 minus neta plus 4 minus neta plus 3.1. Therefore, neta is equal to 3.33 minus 3.1, that equal to 0.2. Where xi is equal to n1 is equal to 0.3 and neta is equal to 0.2. Therefore, n1 is equal to 0.3, n2 is equal to neta is equal to 0.2. Therefore, n3 is equal to 1 minus j minus neta, that equal to 1 minus 0.3 minus 0.2, that equal to 0.5. Therefore, y is equal to n1 y1 plus n2 y2 plus n3 y3. Therefore, y is equal to y1 minus y3 xi plus y2 minus y3 neta plus y3, that equal to 2 minus 6 into 0.3 plus 3 minus 6 into 0.2 plus 6 minus 4 into 0.3 minus 3 into 0.2 plus 6, that equal to minus 1.2 minus 0.6 plus 6, that equal to 4.2. Therefore, y is equal to 4.2. So the nodal coordinates of the triangular element as shown in figure. At the interior point P, The x coordinate is 3.3 and n1 is equal to 0.3. Determine n2, n3 and the y coordinate at point P. So triangular element, first node, second node and third node. First point 1, 2, second point 5, 3, fourth point 4, 6. P is equal to x, y. Therefore, x1, y1 is equal to 1, 2, x2, y2 is equal to 5, 3, x3, y3 is equal to 4, 6. At x coordinate, x is equal to 3.33 and n1 is equal to 0.3 and n1 is equal to z is equal to 0.3. Determine y, n2 and n3. So n1 is equal to z and n2 is equal to neta. n3 is equal to 1 minus j minus neta. Therefore, x is equal to n1 x1 plus n2 x2 plus n3 x3. Substitute n1, n2, n3 values. J into x1 plus neta into x2 plus 1 minus j minus neta x3. Therefore, j x1 neta x2 x3 minus j into x3 minus neta into x3. Therefore, x is equal to x1 minus x3 j plus x2 minus x3 neta plus x3. Substitute all values. X is equal to 3.33, x1 is 1, x3 is minus 4 into j plus x2 is 5, x3 is minus 4 into neta plus 4, that equal to 3.3 minus 3j minus neta plus 4. 3.33 minus 3 into 0.3 minus neta plus 4. 3.33 minus 0.9 minus neta plus 4, that equal to minus neta plus 3.1. Therefore, neta is equal to 3.33 minus 3.1, that equal to 0.2. Here xi is equal to 0.3 and eta is equal to 0.2. Therefore, n3 is equal to 1 minus j minus neta, that equal to 1 minus 0.3 minus 0.2, that equal to 0.5. And y is equal to n1 y1 plus n2 y2 plus n3 y3, that equal to y1 minus y3 xi plus y2 minus y3 neta plus y3, that equal to y13 xi plus y23 neta plus y3, that equal to 2 minus 6 into 0.3 plus 3 minus 6 into 0.3, 0.2 plus 6. 2 minus 6 into 0.3 plus 3 minus 6 into 0.2 plus 6, that equal to minus 4 into 0.3 minus 3 into 0.2 plus 6, minus 1.2 minus 0.6 plus 6, that equal to 4.2. Therefore, y is equal to 4.2.